Alright, today's lesson is section 4.2 polygons. We're going to do a lot of highlighting again today, not a lot of writing. So, to start with, a plane figure. Okay, so let's do with polygons first. Polygons are special types of plane figures made up of line segments. Okay, that's the definition of polygon. A plane figure is closed if we can draw it without lifting the pencil, and the starting and ending points are the same. So, being closed means it's closed. Okay, so this is closed, not closed, closed, not closed, because this has an opening and this has an opening. So that's the difference between closed and not closed. A plane figure is simple if we can draw it without lifting the pencil, and in drawing we never pass through the same point twice. Okay, with the exception of the starting and ending point. Okay, so as long as we don't cross over any lines, it's simple. So this is simple. This is simple, even though it's not closed. This is not simple because we cross over, so it's not simple. So that's the difference between closed and simple plane figures. Moving on. A polygon is a simple closed plane figure consisting of only line segments called edges, such that no two consecutive edges lie on the same line. We call an endpoint of an edge a vertex. And remember, we talked about edges and vertex and things like that when we were doing odds and evens back in Unit 2, if I'm not mistaken. I think it was Unit 2. A polygon is regular if all the edges are the same length and all the angles have the same measure. Okay, so this is not closed and not simple. This is not made of line segments. Okay, now, so none of these are polygons. This is a non-regular polygon because this line is way longer than this line, which is longer than this line. So none of these lines are all the same and the angles aren't the same side. So that makes it non-regular. But it is closed and it is simple. Okay, for both of those. These are regular polygons because all the sides are equal and all the angles will be equal. Okay, so let's look at this right here. We'll box that in. Then remember your names of your polygons. Most of you do. 5-sided figure is a pentagon. 6-side is a hexagon. 4-side, let's do a 3-side first. 3-side is a triangle. 4-side's quadrilateral. 5-side's a pentagon. 6 hexagon. 7 heptagon. 8 octagon. 9 nonagon. And 10 decagon. Okay? So a polygon is convex for any 2 points x and y inside the polygon. The entire segment also lies inside. So convex simply means everything points out. Okay, it doesn't look like it's been hit with a baseball bat. If it's dented in, it's non-convex. Does that make sense? So there you go. I don't know really why you would need the line. I guess it's just a visual thing. But I just look at it. If everything looks like normal and pointing out, then it's convex. If it looks like it got hit and dented in, it's non-convex. Okay, so if you want to box that in, you can. All right. So next, looking at the shapes. Triangles, remember there's 3 types of triangles. Scalene, which means no sides are equal. Isosceles, at least 2 sides are equal. And equilateral, all sides are equal. Okay, so that's your triangles. Okay, then quadrilaterals. Okay, this is the one that people get a little confused because they forget their definitions. Trapezoid, at least 1 pair of parallel sides. Doesn't have to have any equal sides, but 1 pair is parallel. Okay, those are parallel. Okay, parallelogram ups the ante and says, okay, we have two pair of parallel sides. So these two are parallel, and these two are parallel. Okay, so technically speaking, a parallelogram is a trapezoid because at least one pair of parallel sides. Okay, from there, you have a rectangle, which has 4 right angles, and a rhombus has 4 equal sides. Okay, so and technically speaking, a rectangle is a parallelogram, so that makes it also a trapezoid. A rhombus has 4 equal sides, but it's slanted. Okay, it's like a square that got hit by a wind. Okay, but a rhombus, these sides are still parallel, so it's a parallelogram, which also means it's a trapezoid. Now, if a rectangle and a rhombus were to get married and have a baby, it would be a square because it has 4 equal sides and 4 right angles. Okay. All right. So there you go. And that's all on that page. All right. Flipping that over. Polygons and angles. We can use polygons to solve real-life problems such as designing a deck or building a house. However, to do this, we often need to know the sum of the measures of the interior angles of polygons. For example, imagine how difficult it would be to design a hexagon-shaped gazebo without knowing the measure of the interior angles of the floor. So we need to know angle measures, okay, or it'll be all kinds of wompy job, okay? So what you need to know is this. And we're going to visualize using this down here. Okay, find the sum of the measures of the interior angles of ABC. Now, what we have, we know that this line and this line are parallel. Okay, we know that angle 1 is equal to angle 4 because angle 1 and angle 4 are what? What do we call those? Alternate interior angles. Okay, so they are congruent. Remember, that's the symbol for congruent. That means that they're equal. Okay, let's go to a different set of angles. Using that same philosophy, 5 and 3 are equal. Okay, so angle 5 and angle 3 are equal because they're alternate interior angles. Okay, so if you look at this, what do you notice about these 3 angles? So if you look at these 3, angle 2, angle 4, and angle 5 add up to 180. Okay. Now, if that's the case, we can replace 4 with angle 1 because they're the same. And 5 is the same as 3. And we leave angle 2. What do you notice? Those are the 3 inside angles of the triangle. So they equal 180. So that's how you get that the angle sum of a triangle is 180 degrees. Okay, and we're using our therefore sign. We use that back in our logic days too. Okay, now, if you look at this pentagon, I'm going to draw an arrow over here so you can see what we're looking at. Notice that I can draw a line here and here. How many triangles does that give me? It gives me 3. So I have 3 triangles. And how many degrees are in one triangle? So a triangle angle sum is 180 degrees. So I have 3 triangles, each worth 180. So that's 540 degrees. So the interior angle sum of a convex pentagon is 540 degrees. Okay? Now, let's go to the quiz yourself. Let's look at a 4-sided figure. How many triangles can I make out of this without crossing over myself? So, I'll look right here. I can draw and make 2 triangles. Okay? So 2 times 180 is 360 degrees. So that's the interior angle sum of a convex quadrilateral. So let's look at this for a second. So if I have a triangle, I have 1 triangle. If I have, because a triangle has 3 sides. If I have 4 sides, I have 2 triangles. If I have 5 sides, I have 3 triangles. What do you think for 6 sides? 4 triangles. 7 sides? 5 triangles. So you always are going to have 2 less than the number of sides. That's how many triangles you have. So let's flip over, or let's go to the next page. And that's what it's telling me here. Okay, so we generalize the angle sum of a polygon by us saying the number of sides minus 2 times 180 gives us the interior angle sum. Okay? All right. Each interior of a regular triangle, you take 3, divide it in 180, that's 60. Each interior of a quadrilateral, there's 4 sides. Into that 360, it's 90. And a pentagon has 540, so you divide 5 into that. So if it's a regular, each angle is 108. So we can also generalize this pattern. If we take this formula to get our total, and then we just divide it by the number of sides, we can find out each interior angle measure as long as all the sides are equal. Okay? So let's look at quiz yourself. Find the measure of each angle of a regular octagon. Well, an octagon has 8 sides. Now our formula, remember, is n minus 2 times 180 to get the angle sum, then we're going to divide it by the number of sides. Sorry, you can't see that. So we're going to say 8 minus 2. So how many triangles would you have in an octagon? Remember, it's 2 less. So that's 6. 6 times that 180 means that there's 1080 degrees in a regular octagon, or in an octagon. Because it's regular, we can divide it by 8 to figure out each angle, because they're evenly distributed. Okay, so each angle is 135 degrees. All right, imagine that Dancing with the Stars is taking its act on tour to your city, and your advertising company has been hired to design a giant star-shaped billboard to advertise this event. Determine the angle measure of each point of the star. Okay, now, if we look here, let's figure out these measures first. So this is a pentagon. Okay, so let's start with that first. Step 1. We have a pentagon. Okay, so, and it's a regular pentagon. So that means that I'm going to use n minus 2 times 180 divided by n. So that's 5 minus 2 times 180 divided by 5. So that's 3 times 180 divided by 5. So that's 540 divided by 5. So each angle is 108 degrees. So this is 108 and this is 108. All of those are 108. So if I want to find the point of this star, okay, what I can do is find this angle by making a straight line. So step 2, to find this little point right here, I do that point plus 108 equals 180 degrees. So when I subtract 108 to the other side, that dot is 72. This is going to be the same. Now, we need to find out what this other point is. This is a triangle, so we do that question mark plus 72 plus 72 equals 180. So this question mark plus 144 equals 180. So we subtract 180, that question mark is 36 degrees. So each point of the star is 36 degrees. All right. If you need to pause that or rewind it, feel free. Similar polygons. Similar polygons have proportional sides, and this is important. Proportional sides and equal angles. So if I have two things that are in proportion, like one's bigger than the other, but they're proportional, and let's say that this is 10 and this is 5. Well, if this is 6, this is going to be 3, because this one's half of this one. Let's say this one's 8, so this one's 4. Let's say this one is 16, so this one's 8. Then the angles would be the same. So let's say that this is a 72-degree angle. This is going to be a 72-degree angle. So the angles are the same. The sides are corresponding. All right, let's look at this example. Yawman and Rupert, racing against other teams in a wilderness survival contest, enter a deep gorge whose bridge is missing. They plan to cross by cutting a tree to fall across the gorge to use as a temporary bridge. They have measured the distance in 2 right triangles as shown in this figure. Use this information to find the distance D across the gorge. Now, look right here. What you have to do is you have to match this right angle up to this one. So it's almost like this thing swings around. Okay? So it's almost like this thing comes like this. Here's your right angle. Okay? This is going to be 8. This is going to be 6. Okay? So we go 20 goes with 8 as D goes with 6. Then you cross multiply and solve. So this is 120 equals 80D. 8D, excuse me. So we divide by 8, and that's going to be 15. So BC is 15 feet. Okay? That's the distance across the gorge. Okay? And that's all you gotta do. Just match them up, set up your proportion and solve. Remember, your angles are equal. Don't make your angles proportionate, just your sides. Alright guys, I hope you have a great day. Let me know if you have any questions.